All right, 2.5 notes. We are going to skip over this part just because this is going to be in the next section, and this is a little bit long, a few more proofs, so we're going to cut it a little bit shorter. So let's just dive into this one. 2-column proof. Sorry about that. So we're doing 1 to 21. So we're going from here to here. Now I'm going to talk about 2 different ways. Don't write anything down yet. How can we get there? Remember, first off, we can imagine this is not here to begin with. And we have basically 2 general directions. We can go this way and then this way, or here to here. So going left and down, we could go from 1 to 12 by alternate exterior. And then from 12 to 21 using alternate interior. That's one option. Going left and then down, we can go from 1 to 9 by corresponding, and 9 to 21 by corresponding. If we want to go down and right, it's pretty much a similar situation. So I think I said left before, I should have said right. So if I want to go down, I can go from 1 to 19. Sorry, 1 to 20. Okay. 1 to 20, alternate exterior, and 20 to 21, alternate interior. And last but not least, we could go 1 to 17, corresponding, 17 to 21, corresponding. You can choose any of those methods. To start off, we write the same thing as we're given. A is parallel to B, parallel to X, and C is parallel to D. And that's always just given. That's simple. Now, you at this point can choose any way in practice to do these. I'm just going to try to pick a different direction and rules each time just to mix it up. Let me do the last one we just did. I'm going to say angle 1 is congruent to angle 17. And that's by corresponding, if parallel, comma, and you just kind of abbreviate, corresponding angles are congruent. And then we'll sand it, but you see what I'm doing. And now from 17 to 21, I say angle 17 is congruent to angle 21. I say if parallel, again, corresponding angles are congruent. And last but not least, I need to tie now 1 directly to 21. And I say angle 1 is congruent to angle 21 by the substitution property. One to 17, 17 to 21, so 1 to 21 I substituted. And that's it. I'm going to erase all this. If you need to write anything more down, just go ahead and hit pause. Okay, next one. 5 to 14. Here's 5, here's 14. This is a quick one. A parallel to B, parallel to X, and C parallel to D. Given. This one we're done in one step. Angle 5 is congruent to angle 14. We know that because if lines are parallel, alternate exterior angles are congruent. It's alternate because they're on the opposite side of this line, and exterior because they are outside of these 2 lines. And that's it. I'm about to erase it, so hit pause if you need to. Okay, A to B to X again. A parallel to B, parallel to X, and C is parallel to D. Given. Now, 18 and 10. Here's 18, and here's 10. Again, I would imagine just erasing those. Let's just add a little variety. I'm going to go from 18 to 19. 18 is parallel, I mean congruent to angle 19. Vertical angles. You say vertical angle definition. Now I'm going to go from 19 to 3. So angle 19 is congruent to angle 3. If lines are parallel, alternate interior angles are congruent. And then I'm going to go from 3, angle 3 is congruent to angle 10. If lines are parallel, corresponding angles are congruent. And then I tie it up by saying angle 18 is congruent to angle 10 by the substitution property. And if you're still writing, go ahead and hit pause right now. I'm going to erase and move on. Last but not least, I'll confirm. We're going from 7 to 10. Same given. A to B to X, and C parallel to D. Now, you can go any way you want. I'm going to go 7 to 13, alternate exterior. Angle 7 is congruent to angle 13. If the lines are parallel, alternate exterior angles are congruent. And then 13 to 10. I say, if lines are parallel, then alternate interior angles are congruent. Why are they alternate interior? Well, they're alternate because they're on the opposite side of this line, and they're interior because they're in between those two lines. And then I just tie it up. Angle 7 is parallel to angle 10 by the substitution property. And we're finished. That's it.